Hey guys, how are you all? Welcome back to Vedantu's JEE channel, everyone. All those students who are moving from 10th standard to 11th standard, yes, this is an exclusive session for all of you. Yes, those students who are targeting JEE 2022. So all those students who are targeting JEE 2022, whether they are still not clear whether they really want to appear for engineering entrance exam or not, let it be a process in which you are exploring. But yes, again and again saying, the session is for people who are moving from 10th standard to 11th standard. So guys, as you know that exclusively the sessions that we are keeping are for people who are moving from 10th to 11th standard. Now, among these students, I know there are students who are already clear that they want to go for engineering entrance examinations 2 years from now, but there is a good amount of chunk of students who still confused whether to take science or not at the very first level. Okay, so right now this is something where you can take it as a chance or an opportunity to explore how science is going to be in 11th and 12th standard. And if you are a student who's confused between engineering and medical, um, if you are very sure that you want to take science but still there is confusion among these two streams, then I would recommend coming and attending these sessions, specifically on JEE channel of Vedantu and on NEET channel of Vedantu. Attend bio and maths lectures as well, so that you get to know the key differentiating subjects which are mathematics and biology. So which of these you are getting more affinity towards should be your criteria and the way of understanding whether you want to go for engineering or medical. And similar concept applies for people who are confused between taking science or not taking science. Okay, so take an informed call. That's all I want to say here. Okay guys, now enough said about that. You know that we have been talking about things which are going to become the language of physics, which is nothing but mathematics. So very new technique we learned in the previous session as well, that is differentiation. And now the second part of that unit of calculus is what we are going to study today, which we call as integration. Okay, so these are mathematical techniques which were explored by Sir Isaac Newton, not Albert Einstein, but Sir Isaac Newton came up with these techniques of mathematics, and they are very, very, very helpful. And they actually require a lot of understanding of mathematics that you have studied till 10th standard, and that is why they get introduced in 11th standard for all of you guys. Okay, don't worry, I'm going to tell you each and everything that you need to know about this technique, and they are going to help us a lot in solving problems in physics as well as doing a lot of derivations. Okay, now first thing first, for people who are here on the channel for the first time, let me start with my introduction. So guys, this is me, your Suri Sir, also known as Mugambo very fondly by my students, is because when you will crack the examination of JEE in future, Mugambo push hoga. Okay, people, apart from this, for those who are here for the first time on our channel, let me introduce you to all the master teachers who will be coaching you for next 2 years to make sure that you get into the best of the engineering colleges. Yes guys, meet Love Sir. He is your chemistry guru, and this is Arvind Sir. He is going to coach you for mathematics. And yes, this ordinary person over here is me. I will try to coach you for physics. More importantly, the schedule that we are following, this is the daily schedule, or rather I should say it's the weekly schedule for all of you. Daily, if we go one by one, so every day at 8 p.m., sorry, at 7 p.m., you are going to have your theory classes. I want you people to keep a note of this thing, these informations. Okay guys, so every day at 7 p.m., me, Love Sir, or Arvind Sir, we are going to meet you to discuss theory of physics, chemistry, or mathematics. Okay, so remember this time, everybody. And 8 p.m. on specific days like Tuesday, Friday, and Saturday, we are going to meet you with MCQ sessions. Okay, people, I hope it's easy to remember that you have to be on the channel every day at 7 p.m. and you will get to know on 8 p.m. which all days you are going to have your MCQ sessions. Okay, and that ways your entire preparation of JEE is being taken care of. Okay, now if you want to give it a even more serious go towards your preparation for JEE 2022, you know that during this lockdown you are not able to step outside your house, but still your studies should not suffer. So people on Vedantu's app, which you can go on your mobile phone, app store, play store, and download the Vedantu's app, because on this app you will find each and every content related to your JEE preparation, including video lectures, including study material, as well as quizzes and examinations free of cost available just for you. And on top of that, right now the enrollment for the batch for JEE 2022 is also free. Guys, just look at what you're going to get if you come for these batches. You're going to have 4,000 hours of live online teaching by all your master teachers, 40 plus group of IITians with 10 years plus experience each is going to be your coach, including all three of us. Okay, and 750 tests and 3,000 assignments and practical applications. Apart from that, instant doubt solving by your academic mentors. You can watch your replays and recordings of the sessions if you ever miss any of these sessions, and many more things, people. Okay, so all you have to do is follow this link which is available in the description of this video. Also, if you are here on the channel for the first time, everybody, then I would suggest you to subscribe to the channel and press that bell icon as well, because every day a lot of activities happen on this channel. We do academic, motivational, and fun stuff as well. So you don't want to be the last one to know that, rather you want to be the first one to know about all those things. That's why subscribe to the channel, press that bell icon right now. Okay guys, so let's go to the agenda of the day, and that is integration. Guys, as I told you in the previous session itself, that it is the second chapter of calculus, or rather it is the part of a larger stream called as calculus. The first part of that was differentiation, which we have already studied, and now the second part, integration. So let's first understand what exactly the basic concept of integration is. Before I start telling you about the concept of integration, I'll have to give you a quick recap of what was the basic meaning of differentiation. Do you guys remember that? I hope you all do. Yes, whenever there are two physical quantities x and y, so if you are dealing with any two physical quantities x and y which are related to each other by any mathematical function, which could be sinusoidal, that means trigonometric, it could be a logarithmic function. Okay, this f is basically a function which could be from trigonometry, which could be from logarithmic, which could be from exponential, or it could also be from algebra. So guys, if at all this turns out to be the case when you have two physical quantities which are x and y, and they are depending on each other by any means, by any function, then if you plot a graph of them, then on the graph of those uh, quantities, at any point if we draw a tangent, the slope of that tangent was basically the differentiation. And in a practical meaning, differentiation was nothing but change in y divided by change in x. That means the rate at which y is changing with respect to x is what we understand as differentiation, right? Quick recap. Now when we come to integration, so guys, integration, the very first thing that we need to understand about it is that integration is nothing but finding the area that is bounded by the graph, say with x-axis. Means what? This green graph that you show, that you see, is basically the variation of quantity x and y. And if you try to find out the area that is bounded by this graph, say with x-axis, this area, in very simple meaning, is going to be the integration. Yes guys, so in very simple meaning and nutshell, the slope of the graph is differentiation and the area bounded by the graph is integration. Now let's go ahead and try to understand that how we are going to try to find the area. As you know that not every time the area formed will be a regular shape, so if not, then how we are going to do that? So As you can see here, what I have done, I have divided the entire region, say between this point to this point, in small rectangles. Okay. Now all these rectangles will have different values of length. Each and every rectangle's length will be found by putting the value of x in the function, which is y is equal to fx. So if I put the value of x, different values of x, I'm going to get the different values of y, which are representing the length of the rectangles. Okay. And I'm going to keep the width of each and every rectangle same. Okay. That means what? This delta x that you see is basically representing the width of each and every rectangle. So instead of, you know, thinking of finding the area bounded by the graph by a formula which is not known to me, I'm rather dividing the area into small rectangles whose area is something which is very simple, that is known to everybody as length into breadth or length into width. Now what you see here, when I've drawn these many rectangles, you can see that there is some amount of area which is still not covered. Yes, that's quite visible to everybody. Hence, this is not actually the entire area here. So what I'm going to do now, I'm going to increase the number of rectangles. Do you see that in the previous slide, there were 4 rectangles, and now what you see, 1, 2, 3, 4, 5, 6, 7, 8, 9 more rectangles have been formed. You can say I have increased the number of rectangles. Okay, but still, if I put the value of x in fx, I'll be able to find the length of each and every rectangle, which is nothing but fx. And what is happening to delta x if I have increased the number of rectangles? Yes, guys, you can see that as the number of rectangles are increasing, the width of each and every rectangle is decreasing. But what you see here, still there is some area which is still not covered. Yeah. So do what? Let's increase the number of rectangles even further. So when you keep on increasing the number of rectangles, guys, what is happening? As the number of rectangles are increasing, the width of each and every rectangle is decreasing. So can I say that if I keep on increasing the number of rectangles, rather I would want to ask this to everybody, how many number of rectangles do you think I'll need to fill the entire area here? Think about it, guys. Yes, when you will think about it, I will need almost tending to infinite number of rectangles in order to fill this entire gap. In fact, I should say that each and every line over there should start behaving like a rectangle in itself, such that the width of each and every rectangle will start tending to 0 in that case. If I'll have each and every line behaving as the number of rectangle, each and every line behaving as the rectangle, then obviously the number of rectangles will be tending to infinity, and the gap or the width of each and every rectangle will start tending to 0. Yes or no, guys? So in that case, this delta x you will start writing as dx. As you remember from differentiation, delta represents a measurable change and d represents a immeasurable change. So as this happens, what we were doing so far, we were writing the area of each and every rectangle as fx into delta x, and we were trying to add all those areas of rectangle as fx and delta x. The sigma was representing the addition of all such rectangles area. So this is the process that we were following so far. But as your delta x starts to approach the value of 0, or you can say it starts becoming dx, you start replacing, or rather you replace the sign of sigma as the sign of integration. What you see here as this is nothing but the sign of integration. Okay, this is nothing but summation. Integration in the nutshell means summation, and what you are writing as delta x here becomes dx, and guys, this is what we say is the overall area bounded by the graph, that is fx into dx. So in very simple meaning, if you will now try to look at the expression from the perspective of area of a rectangle, you'll be able to see that fx is representing the length of a rectangle, dx is representing the width of the rectangle, and this sign is telling you that there will be n number of such rectangles. You are just adding the areas of length into breadth of each and every rectangle. Okay guys, I hope the basic understanding of integration is clear, and the representation is also clear to all of you. Okay, now there will be two types of integrations. What you have seen here is what we call as indefinite integration, because you don't know from where till where you are going to draw the graph and you are going to find the area. But if you have a defined limit in which you have to find out the area, then the integration sign will have its lower limit. This is called as its lower limit, and this one is called its upper limit. Okay, so how these upper and lower limits are going to help us? They are basically going to help us in getting a definite and fixed value of area bounded by the graph in that range of x1 to x2. So the area under this graph will now have a slight change of limits being written as x1 and x2. But how and what is going to eventually happen is something that I want to tell you here, that whenever you do an integration, the integration will result in a new function. So if you have small fx being written as the function whose integration is happening, then the outcome of this integration is going to be a new function fx, which is capital Fx, and some part of constant will be considered to take care of any area which might be missed out here. Okay, so for people who are preparing for engineering entrance exam, don't worry, you will be studying mathematics definitely in 12th standard, so you will get the clarity of this and differentiation much more and very much in depth, because this unit will take almost a month or more in mathematics classes to learn this, because it has a lot of prerequisite lectures. For medical preparing students, the method of integration, how you solve the problem, is more important. And in physics, we are going to apply calculus to that core, that we are going to see the practical applications in many chapters. So right now, it's my suggestion for you people to see how we are trying to find the area. This is how we are representing it. As I said, this is the length of the rectangles, this is the width of each and every rectangle, and there are such n number of rectangles whose areas you are trying to add by writing this sign of integration. If the limits x1 and x2 are not given to you, you will say it is indefinite integration, and if the limits are given, you will say it is definite integration, and the result of any integration is going to be a new function. And in the case of a definite integration, you are going to put the limits of x1 and x2. How is what I'm going to show you very soon, don't worry. Okay, so guys, one very important thing and a good news for all of you is that integration practically is an opposite process of differentiation. Yep, as you know, like if I ask you what is the differentiation of sine x, I'm sure all of you remember this. The differentiation of sine x was cos x. So the process of integration of cos x will bring you sin x again. As I said, we consider a plus c over there. Okay, so cos x on integration will give you sin x. Any integration is going to be opposite of a differentiation. Okay guys, so what you see here, if the differentiation of fx, which is capital Fx, is small fx, then integration of small fx is going to be capital Fx. In fact, the next table is going to clarify all your doubts in one go. So let's have a look at this, guys. I'll start from here. You remember log x differentiation used to be 1 upon x. So 1 upon x on integration will give you log x. E to the power x on differentiation gives you e to the power x. So that integration also gives you e to the power x. Cosec x differentiation was minus cosec x cot x. So cosec x cot x integration will be minus of cosec x. Sec x differentiation was sec x tan x. So sec x tan x integration is going to be just sec x. Cot x differentiation was minus cos x square x. So cos x square x integration will be minus cot x. Tan x differentiation was sec square x. So sec square x integration will be tan x. Cos x on differentiation gives you minus sin x. So sin x on integration gives you minus cos x. And the differentiation of sin x was cos x. So the integration of cos x is going to be sin x. I hope it's visible to all of you. If not, then have a look at it once again, guys. Here, one thing which looks different, but it's also the similar thing, guys. I want you people to pay attention here in the very first one. If you have to integrate x to the power n, then x to the power n integration will be x to the power n plus 1 upon n plus 1. Remember, n value, not x but n value, cannot be equal to minus 1, because for x to the power minus 1 the case is this. Okay, this is the case where power of x is minus 1, and if you will put minus 1 here, it will become not defined. Okay guys, awesome. Let me take you through some problems here. So if you have to integrate x to the power 2, then how you are going to integrate it? Look x square as the length of a rectangle, dx as the width of the rectangle, by the way, but you will not draw the graph, you will not think of dividing it into multiple rectangles, you will directly integrate it by using the mathematical techniques. Okay, so the integration of x to the power n is this, which means x to the power n, and n right now is 2, so it is 2 plus 1 upon 2 plus 1 plus c, which comes out to be x cubed by 3 plus c. That's your answer. You can try differentiating x cubed by 3, you will get the value as x square only, because x cubed differentiation is 3x square, 3 and 3 cancel, you are left with x square. Okay. Similarly, this is x to the power half into dx. Let's integrate. So x to the power half plus 1 upon half plus 1, which means it is x to the power, the plus c has to be kept here, so x to the power 3 by 2 upon 3 by 2 plus c, or finally 2 by 3 x to the power 3 by 2 plus c. Okay, I think it will not be visible, so have a look at it now once again guys. Okay, so what we have done, x to the power 3 by 2 upon 3 by 2 plus c, so this 2 goes in numerator, so 2 by 3 x to the power 3 by 2 plus c. Okay, now this one is 1 upon x square. Let me write it as x to the power minus 2 dx, where n value is minus 2. So x to the power minus 2 plus 1 upon minus 2 plus 1 plus c, or you can say it is x to the power minus 1 upon minus 1 plus c, or if you try to further simplify, it is minus 1 upon x plus c, and that's our answer. So guys, you can actually differentiate all of these results that you have got. You will get your question back. Yes, these are the results that you should get if you differentiate your answers. And c being a constant, on differentiation the value will be 0. Okay guys, now let's look at some rules which are useful while solving the questions in integration. So first rule says that integration, if it is happening for two functions which are added, fx plus gx, then you just have to integrate them individually. For example, say you have to integrate x cube plus sin x together, then you are just going to integrate x cube separately, and you are going to integrate sin x separately. So x cube on integration will come out to be x to the power 3 plus 1, that is 4, divided by 4, plus sin x, its integration is minus cos x plus c, and that will become your answer as x to the power 4 by 4 minus cos x plus c. You will only write c once, you will not write it as x to the power 4 by 4 plus c and then minus cos x plus c. That will not be required. All you want to show is basically a constant there. Okay. Next one. Rule number 2 says that if there is a constant which is multiplied, k is a constant. If there is a numerical constant being multiplied with a function, so in integration only function will stay, the constant will come out of integration, exactly the same way what we used to do in differentiation. So let's have a look at an example also. If 96 is multiplied with x cube, so for integration you will take 96 out and you will just integrate x to the power 3 dx. So on integration it will be 96 and multiplied by x to the power 4 by 4 plus c. So this on cancelling gives me 4 to the 8 and 4 to the 16, that means 24 x to the power 4 plus c is basically your final answer. Okay, I hope you guys are following. Now this one is basically what we are going to see how definite integration works. Okay, this is more than a property, is basically how definite integration is done. So as I told you, on integration you're going to get a different function which we have been getting so far, and b and a are your upper and lower limits. So what you're going to do, you're going to put this upper limit, you will get fb, you put a minus sign, and then you're going to put your lower limit, and then you're going to get f of a. Okay, I'll show you how it is done. Okay, pay attention everybody. So here when I integrate this one, I get 4 x to the power 4 by 4 plus 6 x to the power 3 by 3 minus 10x plus c. Okay, and my limits are 1 and 2. So 4 is getting cancelled, this cancels it 2 times, and now I'm going to put my upper limit. So when I'm going to put the upper limit, only 2 will be put everywhere wherever I see x. So 2 to the power 4 plus 2 into 2 to the power 3 minus 10 into 2 plus c. That's how I put the upper limit, that is f of b. Now put a minus sign and put the lower limit. So that is 1 to the power 4 plus 2 into 1 to the power 3 minus 10 into 1 plus c. So guys, you can see that because there is a minus sign, so this c and this c will get cancelled. And now what I am getting is 16 plus this is also 8 into 2, that is 16 minus 20. Then here I have minus 1 minus 2 plus 10. So this is eventually going to be 32 minus 20 is 12, 12 minus 2 is 10, 10 and 10 20 minus 1, so final answer is 19. That's our final answer everyone. Okay, let me show you one more example how we integrate. So integration of sine x is, as you all know, is minus cos x. Okay, and the limits will be 0 to pi by 4. So let's put the limits. So first I put the upper limit, so minus cos of pi by 4 and minus minus plus cos of 0. So the value of cos pi by 4 is cos 45 degree, which is 1 by root 2, and cos 0 is 1, so answer is 1 minus 1 by root 2. You can obviously simplify it if you want. Okay guys, I hope you guys are following how we solve the definite integrations. Okay, let's try one more, in fact 2 more questions here. So this one, if I integrate, I get x to the power 2 by 2 and e to the power x remains as it is, and the lower limit is minus 1, upper limit is plus 1, and this time I'm not going to use or put any constant, okay, because any which way it gets cancelled. So on putting the upper limit, I have 1 square by 2 plus e to the power 1, and then a minus sign, minus 1, if I square it, it will be still 1 by 2. So I'm just writing it as 1 by 2, and this is e to the power minus 1. So what do I have? I have 1 by 2 plus e minus 1 by 2 plus 1 by e, because this is e to the power, okay, there will be a minus sign. Okay, this will be a minus sign here. So let's put it. So this half and minus half get cancelled. I have e minus 1 by e, or you can call it e square minus 1 by e as your answer. Okay, now this one. So if I integrate sec x into tan x, just think of it as whose differentiation is sec x tan x. So yes, integration has to be sec x, because if you differentiate sec x, you will get sec x tan x, and sec square x will be integrated separately, and its integration, you have to think whose differentiation is sec square x, that was tan x. So sec x plus tan x, no c I am putting here because that is a constant, and 0 to pi by 4. Okay, so let's put it. So sec pi by 4 plus tan pi by 4, this is your upper limit, put a minus sign, sec 0 plus tan 0. So sec pi by 4 is sec 45 degree. So cos 45 degree is 1 by root 2. So this will be root 2 plus tan 45 degree is 1. Put a minus sign. Cos 0 is 1. So sec 0 is also 1. Yeah. And tan 0 is 0. So what do I have? I have root 2 plus 1 minus 1. These two cancel. My final answer is just root 2. Okay guys, I hope you guys are following this and are able to solve the questions along with me. Great. Now guys, let me tell you how things are useful in physics. Okay. Now, as I said earlier as well, in the case of differentiation, I told you people that there are different quantities that we obtain when we differentiate a quantity or two quantities differentiation. If you use change in one quantity upon change in the other quantity, we get a new quantity. So similar will happen in the case of integration. Like velocity was the differentiation result of displacement with time. Acceleration is basically the differentiation result of velocity with time. Similarly, this is second law of motion. You will study this with me, don't worry, very soon. Force acting on a body is basically the differentiation of momentum with time, and current is basically the differentiation of charge with time. So if you do just the opposite, if you find out the integration of V, you are going to get the displacement. If you integrate A, you're going to get the change in velocity. If you integrate force, you will get the change in momentum. If you integrate force with displacement, you will get the work done. If you integrate current with time, you will get the charge. Don't worry. Much of physics behind it, you might not be aware about it. But what is important is that if the process of differentiation gave us one quantity, say quantity 1 on differentiation gave you quantity 2, then quantity 2's integration will again give you quantity 1, and that's what we are going to do. So let's have a look at some examples here. Say you have a force which is given as x cube plus x square plus x plus 1. We have to find out the work done in displacing the particle from x equal to 2 to x equal to 4. So this is basically a practical question, and the physics behind it says you're not aware about the physics, so don't worry. It, in fundamental meaning, it is basically drawing a force and displacement graph, which could be x also here, and say whatever that graph comes out to be, you are interested in basically finding the area of this graph between x equal to 2 to x equal to 4. That's basically what you are doing here, guys. Okay, and how do you do that? You say that work done is basically integral of f into dx, and you say that force is given as x cube plus x square plus x plus 1. Yes, that's the most common integration that we'll be doing, that is x to the power n, and same is going to be the case of differentiation. And put a dx here, and the limits of x are changing from 2 to 4. Okay, let's see how we are going to get it. So x cube on integration is x to the power 4 by 4 plus x to the power 3 by 3 plus x square by 2 plus 1, and you're going to put the limit from say 2 to 4. Okay guys, so this is 4 to the power 4 by 4, putting the upper limit, 4 to the power 3 by 3 plus 4 square by 2 plus 1. Okay, and minus 2 to the power 4 by 4 plus 2 to the power 3 by 3 plus 2 square by 2 plus 1. Okay, it's going to become a lengthy question. So 1 4 is getting cancelled, and what I'm getting is 4 cube, which is 64, plus 64 by 3 plus 16 by 2, which is 8, plus 1, and in the other bracket I have 2 to the power 4, which is 16. 16 by 4 is 4, plus 2 cube is 8. 8 by 3 plus 2 plus 1. So guys, I'm not getting into further simplification of this thing. I hope the idea is clear. The idea is not to teach you the calculations here. Rather, the idea is to tell you what you are going to eventually get is the work done in joules. Do tell me what you are getting as the answer. I'll also respond later on in the comment section. Okay guys, do tell me this in the comment section, because there will be no homework question today. There will be an assignment, don't worry, in the description of the video, but in the comment section I want you people to tell me, after simplifying this, what is the value that you are getting for the work done here. Okay guys, I hope you will be able to find, and do comment not in the chat box, but rather tell me the answer in the comment section. Okay guys, awesome. Now let's have a look at this one, everyone. Now this question says that acceleration of a particle is given by 2t cube plus 1 meter per second square, and we have to find out its velocity at t equal to 3 seconds if the initial velocity is 0. So again, what it is trying to tell you, that if you draw a graph between acceleration and time, and whatever that graph comes, you have to basically talk about the change in velocity, which is going to be the area. Okay, and that you are speaking from t equal to 0 to t equal to 3. So I'm saying that change in velocity will be nothing but the area bounded by a dt. That means a acceleration time graph changing from 0 to 3. And what is acceleration given as? It is 2t cube plus 1 into dt, and time is changing from 0 to 3. Okay, okay, I hope screen is visible to everyone. So integration 2 won't be integrated, you will be integrating t cube dt plus integration of 1 dt, which is just the integration of dt. So this is 2, t cube on integration will be t to the power 4 by 4, plus how you are going to integrate 1, it's basically t to the power 0. So on integration you will have t to the power 0 plus 1, that is 1 divided by 1, or simply t, and put the limit from 0 to 3. Okay, so let's put that. So this is 1 by 2 and 3 to the power 4 plus 3. This is your upper limit, minus everything will be 0 on putting the value as 0. So guys, change in velocity, which is final velocity minus initial velocity, is coming out to be 3 to the power 4, which is 9 into 9, that is 81 by 2 plus 3. And by the way, initial velocity is mentioned as 0, so the velocity looks like 81 plus 6 by 2, or you can say it is 87 by 2 meters per second. That's that's basically our answer. Okay guys, so we are going to solve a lot of such questions in physics. This is where we will actually get into kinematics from, and later on we'll find out all those quantities which were mentioned earlier in this slide, what you saw here. Yeah, all of these will be done in physics. In fact, not just these, many more. So guys, this brings us to the end of the session, but before I tell you about the Telegram group, let me remind you that I want you people to tell me in the comment section what is the answer that you are getting over here. I want to know the value of the work done. What is the value of work done that you are getting in the comment section? Okay, so people, this brings us to the end of the interesting session of integration, and if you are interested, you can come to our Telegram group for more assignments, study material, and the daily updates of what is happening on our channel. All you have to do is follow the link which is available in the description of this video. And guys, if you enjoyed this session, yep, do hit that like button, people, and tell your friends as well. If you found this useful, let your friends also take advantage of it. And if you are on the channel for the first time, do subscribe to this channel and press that bell icon so that you are not missing out on any notification which is related to anything happening on this channel, which could be any academic, non-academic, or motivational session for you. Okay people, so this brings us to the end of the session, and I'll take your leave on the note that even when we are under lockdown, the learning won't stop. So people, keep studying, keep enjoying physics, keep smiling, and more importantly, stay inside, stay safe. Bye bye guys, take care.